Man, we are just so excited to be back for another exciting MSD podcast. Here we are, season 2, episode 5. Right, time is flying by. Days are going by quicker than we can even imagine, and it brings us to our topic today. Is we're going to dive into protecting your building's electrical systems with the unknown out there in the power grid. And today, so happy to have a special guest with us today, Dana Beatley. Dana, welcome.
Thank you. Good to be here.
I mean, you bring so much electrical expertise to this company, and we can't thank you enough for what you do on a daily basis.
Well, I appreciate that. That's probably why I lost my hair. You can't have all this knowledge and a head of hair too. So
it's a good thing it wasn't from an electrical accident, right?
Yes. Right? Yeah, I didn't stick my fingers where they didn't belong.
So, when we talk about the importance of the electrical power grid, its role for facility managers in maintaining their business operations, making sure they have consistent, adequate power, is such an amazing thing when you have it. But when you don't have it, there's a lot of major questions going on, right? Major disruption.
Yeah. With the move of everything trying to go electric, the demand has never been higher than it is now, and the power grid has just never kept up with the demand to the amount that we use it nowadays. And there's really a push now to go even farther. With the current administration, I'm sure the cars and stuff will probably slow down a little bit, but they're coming. I mean, it's going to be a push. That grid is stressed out, and you have issues that can cause you problem in your buildings.
Tell me, just overview, right? I mean, for the listeners out there that, maybe they know, maybe they don't know, but just how's the power grid work?
Power grid is, you have generation stations. So you have coal-fired, you have nuclear. The coolest one is hydro. Out west, they do use that a lot where there's nothing out there to generate. They harvest those dams, use that water to generate power. There's natural gas generation. Anyhow, the power gets generated from one of those stations, and then it goes to a transition system or a transfer system. So you have transition lines that take it all over the country. And then the local power companies that are in charge of their local area get delivered that power, and then they distribute it on their own part of the grid out to your business or to your home. And that takes multiple things. You have substations, you have all kinds of ways and things that they have to distribute that power, that it causes trouble as well.
Mm-hmm. Yeah, and so as they're going, or it's a new development, you're putting in basically a transformer to be able to collect all the power. Yeah. It's kind of in this hub zone, right, to where then you can start kicking it out further down the channel as buildings are built and areas are needing that power requirement, right? Mm-hmm. Okay, so when we talk about all this power, and it's just being pushed from that local utility power holder, and they're pushing it out to the grid, and it gets to a specific transformer. How does that call for where the power is needed on the grid?
Okay, so they have ways to watch what they're, just like you have in your plant. You have a plant or a home. You have a way that you can check and see what your load is and your current load is. They have ways to watch those lines locally to see what the demand is. Now, you can have, let's say, a neighborhood that is fed from more than one substation. So if you're in a industrial neighborhood and you have a company that's working there, let's say that it gets hot, HVAC kicks on, everybody's HVAC kicks on, they see the load going up and a substation is overloaded, they have the ability to switch you to another substation to feed you power. Okay? One of the problems that causes is every time they make that switch, it sends a blip down the line, which is a transient that we see that come through plants that can actually, unfortunately, cause motors to burn up, loose circuit boards. And today, everything is more electronic. So it's important to be able to protect yourself against that, because you can't stop it. It's not going to get stopped at the utility level.
It's reminding me of, I love the Christmas Vacation, National Lampoon, and Clark Griswold, he gets up there. I mean, think about all the time it took to put up all those Christmas lights. But the scene where he's trying to find, after he finds like where the breach is at, right? Like he's continuing to try to plug it in and get it to work, and finally that switch comes on because he didn't use the best electrical practices, but that's a different podcast. But
I love that movie. It's one of my favorite movies ever.
The lights on the ceiling, on the roof, and he's like, Russ, we plugged everything in, right, Russ? I mean, every bulb's good, right?
Yep.
And so then he finally gets it, and they had to do the emergency generator. I think that
they turned
like
a reactor.
Nuclear.
They turned an extra nuclear reactor on so they could provide enough power. And a good example of what happens when the air conditioning comes on. Look at Texas. Was it a couple of years ago that Texas had brownout issues that were really bad, and they did not come up. I don't know that they've even fixed that problem to this day, that if they get a worst case scenario, the grid is just really not set up to handle all that right now.
Absolutely maxed, no backup, limited, zones can be fed. And that also leads to where sometimes, people are down for multiple days, multiple weeks, right?
Yeah.
And I remember that last year in Texas. You're right. That's pretty crazy. Like, just imagine like if you're in your residential home or in your business and you're like, I don't know when power is going to come back. And that gets into, having the necessary backup, your own means, whether that's solar or generator, to where you can run independent and you're not relying on the grid, right? In cases like solar, you could actually push back to the grid. Right?
Yes. Yeah. And that's just one problem. Right. We've got multiple problems that we can talk about that this issue is causing. A lot that we're seeing here at MSD is we're having, with that switching, sometimes you'll see if the load goes down, the voltage goes up.
Oh.
Okay? So they'll make a switch and the voltage goes up, and we'll see problems with that. So we have had instances where we have to regulate that power coming in because it's overdriving someone's system, and their drives are kicking out for over voltage. And then you have the same thing. We have other customers that have called in and have problems with under voltage on the end of the line, and they have no plans to fix this problem. It's been this way for a couple of years. What are you going to do? Give us a call and we fix it. Now, there's safeguards that have to go along with fixing that, to make sure you're watching what that voltage is. So if it does change again, what if they change to another substation and it pops back up? You have to protect against that. So we're looking for, one, protect yourself from not having any power. Two, protecting yourself from having over or under voltage. And then we talked about surges, transients. Transients can be caused from internal issues, or they can come from outside. Anytime something dramatic happens, lightning is a very big transient. I mean, that's a violent thing. But as violent as you think it is, a very small part of what that lightning produces actually comes into your facility. But what comes in can cause havoc unless you're protected. Right. You can have problems within. You can have a motor go bad and spike and cause a problem on another machine back through your own system. So we go through, we see, make sure your problems are not a high voltage problem, a low voltage problem. Do you have transients? Okay, where are those transients coming from? So this is a puzzle that has to be figured out first before you can actually give a solution. Do we have solutions? Absolutely. But it takes a little more than just guessing what problems are.
So from a facility standpoint, and there is the power, it's being pushed, it's, there's a building need and it's calling for power, right? Talk to us about when it comes into the building, what does that process look like, and how's that power distributed from there?
Okay. So if you have an industrial facility, that's the biggest one that we would work on and talk to. You have a
Gotta
service.
love industrial facilities, right? I
Yeah.
mean, it's like, look at all the amazing stuff happening inside these facilities across the country.
Yep.
Definitely high power needs too, right?
Doing my job is like, how's it built on TV, or, how do they do that? That's the cool thing I get to experience, is I get to go in and see how this stuff is done.
That's right.
But then I got to make sure that it works so that happens. So it comes into a service. Usually in a larger facility, you're going to have 40 volt service, and they have a main. They should have a main. It's not always done that way. It's not required, but what's required is not always the best. But have a main that comes into that, and then that gear will have different switches that feed to different areas or different pieces of equipment in the building. And then at some point, we didn't talk about the different voltages. You got to have 120 volt power to run your computers and everything. So you're going to have a transformer somewhere that takes that 480 volt, changes it over to 12208, and provides you service for your computers. Lights can be run off the higher voltage, but lights are usually run off of 12208, which is off of that transformer.
Lights is a good one too, because that demand's kind of going down with the LED, right?
It is.
You're seeing these energy efficiency improvements being made. So now the load of a building in certain areas of what historically would have been a little bit more on the lighting, now with the LED, less demand.
Which is why we're in the issue we're at now. So when the power companies were charged with, you got to do something because the grid can't handle this.
Yeah.
So we went through and we did all these lighting upgrades. The cheapest thing for them to do was to pay for the lighting upgrades, right? So that brings their demand down. Well, but that didn't allow for all the stuff that's coming in that's new.
That's right.
So yes, we did a good job at bringing that much down, but we more than found stuff to take over what we had saved.
Yeah, and I think you're right, because I know here at MSD, and we see clients, we're trying to help them navigate through these situations where we're seeing very highly sensitive boards, and these big air handlers and fan wheels and pumps that run off some sort of a drive or a board or something regulating the power to say turn on, turn off, function, go, speed, right?
Yep.
And they get these surges or these spikes that can fry the board and directly affect that piece of equipment that board is telling to turn on or off.
Yeah. The thing with the power companies, they only give you plus or minus 10% on that voltage.
So you're telling me that their only deliverable is plus or minus 10%.
That's exactly
so
what
that's a wide range.
That's their promise. We'll give you plus or minus 10% of the voltage we tell you we'll supply.
And these boards are built for
3%.
3%. So you're telling us as a facility owners out there, we need to be very, very careful, right?
Yes, absolutely.
And what are some of the measurables as facility owners? What are some of the measurables they can do? What would be your recommendations to protect their facilities?
On the large equipment, let's start with drives. The drives have alarms on them that shut that thing down. So it is annoying when your drives keep shutting your equipment down, but the thing that's not happening is you're not losing equipment. So on large equipment, a drive helps a lot because it gives you a means of checking up on things. Transients, the way to get rid of transients is to put in surge suppressors.
But you're talking transients, could be lightning, or it could just be a power surge from the grid.
Switching that from substation to substation
because of the demand. Or
yeah, a transient is a momentary within just a minute part of a cycle,
which is a spike.
It comes through. You can't even see it unless you have very advanced equipment. If you're putting it on there, you won't even see it come through, but you will certainly find it. Yeah. With equipment being out. So how do you protect against that? You put a piece of equipment in that it offers a lower impedance to get to ground. It takes the hit so that your equipment doesn't take it.
And what's that device called?
They call them a transient voltage surge suppressor. They've changed it now to a surge protection device to make it easier. I said easier, and then I stumbled through what it was. But
we were doing those integrated control measures, right? Those ICMs.
Yes.
We were putting on like the boards at that particular unit, and now we're actually attacking the main panel feed.
Yes.
And putting the surge protection devices on the main panel feed to the whole building. So I think that's really important that our listeners hear that, right? Like,
yep.
Protect your overall building, not just that one individual board at that one piece of equipment.
Right. I mean, ideally, the most protection comes from putting that device as close to the problem as possible. But you don't know where the problem's coming from.
That's right.
So is it internal, external? Probably not internal, probably external. So you protect your and the kind of insurance that this offers, it's not that expensive compared to the amount of money you're going to pay in damages. So you put this at the service, and it protects the whole service. So anything comes in, it takes the hit. And these things are nice. They have counters on it. You can see how many times it's taken a hit. How many times has this saved me? And then they also have indicators when they're at the end of their life. They will let you know. Some of the more expensive ones can be revitalized. Others just simply get replaced depending on the level of protection that you decide to go with.
Yeah, that's key from the surge standpoint. What other measures do you recommend for clients to protect their electrical infrastructure inside their facility, in addition to the surge, in addition to the ICMs? What else can they do?
I would suggest a good preventive maintenance program. It's just like your body. The way to keep your body able to handle any kind of shock it may get is to keep it as healthy as possible. Yeah. Electrical systems tend to get kind of ignored because if you turn the light switch on and it comes on, everything must be okay.
If I turn the switch on, the power should be there. Like,
yeah,
that's like, you talk about it, like when you walk into a room and you are having a power outage and you're like, well, what the heck? I turned that switch on. The light didn't come on. You're like, well, what am I supposed to do now, right? So
right.
You go to your breaker and you're like, well, the breaker's on. Like,
yep.
What the heck, man?
You start searching for answers.
That's right.
So what if I told you that if I checked once a year, I could tell you when that switch was going to fail. And so you can do it when you want on your schedule.
I think that would be helpful. I think
okay.
I could see the purpose behind that, of having a conversation with you.
Okay. So we're talking a light switch in an office, right?
Yeah.
Let's talk your major manufacturing machine.
Okay.
We have a manufacturing facility back here. We have a main line that runs our ductwork, right?
Yep.
What if that switch goes bad and that thing's down?
MSD Sheet Metal Manufacturing.
There you go.
Eric Coulter, great guy. Go ahead.
And that's big money, right?
That's right.
So if I go and I check that and I tell you, hey, this looks like it's getting ready to fail one Saturday or 1 week when they're going to shut down or something, you really ought to change that switch, and then it never fails because you get it changed out. That'd be awesome, wouldn't it?
I would say, yeah.
Okay. So we can come in and do an infrared scan of your facility, and when electrical devices have issues, they generate heat. An infrared scan shows you excessive heat, shows there's a problem, and lets you schedule the repair of whatever issues that you would find.
So like power would still be working, but you're able to just kind of do the infrared, and you could say, hey, there's a breaker, or there's a panel, or there's a circuit that is hot, or could be actually taking on more load than it's designated for, right? Which is allowing it to get through.
Yeah.
So then that really kind of allows you to see how the power is being distributed within the building and what components are
absolutely
need to be addressed.
Absolutely.
All right. What do you have to offer? Like and it's a term that we need to be very careful with, right? Because that plus minus 10%. There's a thing called these surges and these spikes, and it's concerning, right? Because it could be your house or your business or any facility, right?
Absolutely.
So, what do you recommend if a particular facility owner is thinking that they're getting some spikes? They're losing some boards here. They got some computers that are being fried here, there. Like, what would be your recommendation how do you verify what's coming in from the grid?
First thing we go and do is we look at what the voltage levels are at. And then we see if you have a high level or low level. But then even if we find that, it could be something else. I'm going to give you a kind of interesting subject or interesting story here. We had a customer that was having trouble with a drive kicking out, 2 drives kicking out. And we went to check it out. My first assumption is, well, I told the technician, we need to look and see, is there over voltage, under voltage? What's the problem with this? And so he went down and we put a meter on it to check it. And they had an over voltage problem, but not that it didn't look that imperative. Fortunately, the guy that went down to take the meter off was also our drive technician. And so he got in the drive and he was punching around. And so we've had so much trouble in that area with transients and voltage issues and stuff. I automatically switched to that, thinking we've got a problem. This instance was they had the drive mounted over top of an oven and it was getting cooked.
No kidding.
Yes. So
so the heat load just fried it.
That shows you how much problems we've had with these, voltage issues and transients and stuff, that I automatically went there.
Yeah.
Because we were having so much trouble, especially in that area down there. And I went there, but that was another thing. It's important. The story was told. It's important to you spend the time to narrow down what the issue is. There's no use putting a Band-Aid on something that's not really your problem.
Yeah.
So you have somebody come out that knows what they're doing and checks it out. I've already said I'm human. I assumed something else, but through testing and checking it out, we found out that the real problem is the heat. So the drives are getting moved away from the heat, and then we're going to address the voltage issue. We're watching to make sure that voltage stays consistent. You can't just arbitrarily change voltages. I had mentioned drives before. That works really well because they have a high and low limit. So if you have to jump up your power to make that machine happy, if by some chance the utility ever changes, that drive's going to tell you.
Yeah. So
that you can correct it again.
It keeps you within that range.
Yes. Yep.
Yeah. No, that's good stuff. I mean, I know we covered a lot, and yeah, we're having some fun. But this is seriously, this is a major concern when we look across the grid, and trying to really kind of manage this 20% deficit with a 10% over or a 10% under of what the grid's actually producing.
Yeah.
I know we discussed a lot, but just to kind of recap a little bit in closing here, know that there's options, right?
There are options.
Companies that are certified that people can call. We highly recommend that, right?
Mm-hmm.
As the power's coming in, there's infrared technology out there where we can really kind of break down how is that power being distributed. There's surge protectors that can be put on the main panels.
Yep.
There's ICMs that can be put on any electronic board or highly electronic device that is very sensitive to these spikes, these transient spikes that can happen even with force majeure, which could be a lightning strike, which could be new developments going on, rural areas where there's not a substation that's kind of regulating that, and it's just flowing and pulling and receiving. What were some of the other things we talked about?
Well, I wanted
the maintenance plan.
One of the things that popped in my head when you were talking is that a lot of our manufacturers on the HVAC side are not they're not honoring their warranty if you don't put some of these devices on.
Yep.
So in our special projects, they're putting in the price when they give you a price to change a unit out. It will have surge suppression on it.
Good point.
It will have phase monitoring on it.
Yep.
To just to get you your warranty. So that's how big a deal this is getting. You were talking about stress and how important it is. It's not getting better. I'm not a utilities guy. I can't tell you what they're doing exactly to correct it. I just know from our service standpoint, it's getting worse.
Yeah. And the other thing too is that standalone. So we do have clients that, we've obviously, help support, like if there's means, like we talked about, additional backup capacity, if you're having a lot of power loss or inconsistencies, and you don't want your manufacturer or your industrial facility to be down without power for days, like we can do generator, we can do solar backup. I mean, these are options that, the electrical industry has available to be able to keep buildings functioning, right, and just really trying to just reduce that downtime.
The nice thing with all of this, including the generators and everything, it can all be sized to your budget. You tell us how much money you have to spend, we can tell you how much you can cover.
Yeah.
Even the generator. Okay, you want a generator, how much do you want to back up? Mm-hmm. What's very important to you? What can you live without? What you can't? Yeah. So that you're not spending any more money than you actually, can afford to spend. Give you the best value we can possibly give you.
Yeah, I tell you, man, I can hear the passion as you talk about making sure that we're keeping making economical sense, but also being efficient, right? And making
Absolutely.
Sure that we're there to protect, and that goes for anybody out. I mean, this is life safety. This is a big deal. This can be really, really costly, and it's really important that we continue to try to, be proactive in our conversations and try to really get this out there, because 20% range is a big deal.
Yes.
Plus 10, minus 10. How much are you getting at your facility?
Yep. It is no longer the light switch.
Yeah.
You can no longer just, as long as it's on, it's fine. And people are going to start learn. You're going to learn it the easy way, or you're going to learn it the hard way. You're going to listen to what we have to tell you. We'll give you our honest opinions. We'll give you information to back it up, or you can call us when it, quite frankly, blows up.
Yeah, and we'll be there either way, right?
Yeah.
Right?
Yeah. It's like the old commercial. You can pay me now. You can pay me later.
Yeah. we most importantly is just take care of the needs, right?
Absolutely.
Power serious.
Absolutely. No more, no less than what someone needs.
Yeah. Dana, so much expertise, right? You've made a great career in this field. We are so happy to have you part of this company.
Thank you.
And working with clients and just making sure that every building has adequate power and they're protected. And I love your passion for it. Love the fact that, I get to work on your team. So just thank you for taking the time I know we had a little bit of fun, but to push this message out. Thanks for being a part of it.
Not a problem. Anybody wants to talk about this, obviously I don't have a problem talking. But I can, it's not as hard. We covered a lot of stuff really quick. It's not hard to understand if, you have a short conversation. It'll be worth your while to check into it.
Awesome. Thanks, Dana. Appreciate you, man.
Thank you.